So a little bit about myself. My name is Mark Baggett. I am the course author for a couple of different courses, SANS 573, 673. 573 and 673 are all about teaching you automation with Python, which is obviously some of the stuff we're going to be doing today. I'm one of the SANS faculty fellows, and I'm the Chief Technology Officer for SANS Internet Storm Center. A couple of different pieces of information there. I'm not going to read my whole bio to you. I will tell you a little bit more about the SANS Internet Storm Center. Though SANS Internet Storm Center, if you're not familiar with it, it's a great source for threat intel. We do have DShield, which is a community-based database. We've got hundreds of distributed honeypots out there, and those are collecting up all kinds of great attacker information. We collect it up and put it into that DShield database where you can log in and gain access to that information. Then we have volunteers who are monitoring that information as the SANS Internet Storm Center handlers, and they then post journal entries out there, the SANS Internet Storm Center diaries that are posted every single day, where they're going to sum up the different attacks we're seeing, talk about the release of new tools and things like that. And you can get all this from isc.sans.org. A little bit about 573, 673. 573, I'm going to teach you all about coding. I got 130 hands-on, more than 130. It's really a hands-on intensive class. And of course, there's the GPYC certification that comes along with that. So if you're interested in learning how to code and really understand the different attacks that we're talking about, as well as just, future-proof your career. If you look at everything that's emerging now with AI, cloud automation, adding automated threat intelligence as you consume all of these different log sources and finding threats in an automated fashion, automatically going through your proxy logs, finding these URLs that John's telling you about. I'm going to teach you to do that. Specifically, we have labs in that course where we talk about automating the analysis of logs to look for artifacts just like that. And then there's 673, which is the advanced 573. We pick up where that left off, and we're going to build more advanced topics from there. Okay. This lab, or this particular presentation, I've got a little web app that we're going to be walking through. And if you would like to do this on your own and walk through this at the same time I do, well, there's the URL for you. So I'll walk through. If you have a machine with Linux installed and you want to go through and do this lab, you'll be able to work through this lab with me at the URL you see there. So with that, let's go ahead and jump into a VM. Oh, since I'm here, let me also mention that if you're not following me on Twitter, I just released a brand new incident response and forensics application just this week. Scrum Dump 3.0. Here I have it on my desktop. I'm going to run it real quick just to see how it is. And again, I just released this this week, so let's hope that this goes well. And you can get this in my GitHub, github.markbaggett /Scrum Dump. You'll see the release there. So Scrum Dump.exe, what it does is it is an incident response application that is really pulling from the System Resource Utilization Management database. If you've never seen it, if you go into your task manager here, you've got this in your task manager, we've got some app history that is being kept in here. Let me see if I can expand this window. There, app history here, where you've got information about things that have run on your computer over the last 30 days. And so this information is displayed here, but it's very limited as to the information that they show you there. I've had plenty of times when I've gone into incidents and said, hey, do you have any EDR, any type of application logging in place? And the answer is no, we don't have any of those things. And in those cases where you get to an endpoint, the EDR was broken, there is no EDR, this can be your lifeline, because it's going to tell you every process that's run on that application for the last couple of days. First thing I need to do is create an output directory. So I'm just going to put a new folder here on my desktop. I'm going to call this output. I think I'm going to call it output. Oh, wait, I got to release my mouse over here. I'm going to call this output. All right, there we go. And then I'm going to just browse that folder here on my desktop, output, say, all right, I want to put the stuff there. And that's where all of my results and logs and everything else are going to go. The next thing you got to do is you got to select the srudb.dat file. Now, ideally, you'd be getting this from a forensics image and not from your live machine, because this file is locked by the operating system. However, this particular version, if you do give it the one that's on your computer, it's going to, well, accept that, and it's going to try do its best to grab a copy from from your system by going through the volume shadow copies. It also needs that software hive, and it's pointing you to those default directories where those things exist. All right. Now, this first step, it might work, it might not. Really, I'm depending upon the operating system to try and extract that file, and it's got to get a copy of it. It does do some detection to see if, hey, if it's able to successfully retrieve that file. If it's in use, if the database is being updated at the time it's trying to retrieve it, you'll get this error message. So this is a rather unfortunate outcome of my demo here. But it says it's not up to date, and integrity check has found that the database is corrupt. So what I'll do is I'm going to cancel this. I'm going to then cancel that. And I'm going to close this down. And then I'm going to come in here to my output directory. I can see that it did extract some data, but it's all corrupt. All right, so let's try this one more time, see if it works this time. If the database is in use, if it's being written to when the things tries to extract it, it does give you an option there to repair it. And if you can try and repair it, and that might get you there. But the best thing to do would be to just rerun it. Ideally, if you can, reboot. But I'm not going to reboot because, well, we don't have time for that. I'm going to select output here. And let's try this one more time. If this doesn't work, then I'll come back to it perhaps after the presentation and see what's going on. All right. So okay, actually, I just reselected my old Scrum there. In my output, I thought I erased everything. I didn't. I must have selected that, clicked erase. Oh, look, I went back a directory. It's not select. All right, that's what I wanted to do. Select it, and I'm going to right click, delete. There we go. If you already have a Scrum in an existing directory, what it'll do is it'll let you reanalyze that same file. So that's what happened there. So I'm going to rerun this thing here. We'll try this once more, and then we'll get to the presentation that we all came here for. But I'm just excited because I just released this week. We're going to select those default locations, let it create that volume shadow copy, extract that file. And there we go. That time I got a good extraction of my database. Now, the first thing that happens is it analyzes the database and your software hive, and it builds this configuration file. If I click this edit button, it's going to bring up this little JSON configuration file, where here I can see the names of all of the wireless networks that I've connected to. So yeah, there you go. There's a little too much personal information being displayed. All the wireless networks that I've connected to, the names of all my networks. And then we scroll down here. It's got some tables setups, like the names of the tables, how I'm going to convert some fields. So if they were to add new tables and things like that, it's simply a matter of adding them to this JSON configuration file. I can create calculated fields that are basically Excel formulas that I'm going to say, oh, I'm going to add this new column called a total bytes, which is going to be the sum of this column and this column, and we're going to add it to the name of this table. That table GUID there, I can figure out what that is by going to these table names up here, known table names. Let's see, skip tables, they're down here somewhere. I got my table names are defined in here somewhere. Oh, here they are. All right, here's the names of those GUIDs and what the tables are. And then this is all of the information that it pulled out of the process with the names of every service that's run on my host, every username that's been on my system. These are the fields that are going to be in my database. So if I was looking for a particular user, or if I suspected that this service was problematic, then I could add some tag words here, suspect, right? Or something like that, so that that word would then appear in the database. The other thing I can do is I've got this dirty word search. Well, where did that go? I got this dirty word search right at the very top where I can, my scrolling is not working that well. I can come up here and I can say, hey, you know what? If anything contains the name backdoor in it, then I'm going to highlight it in blue. Or if anything contains cmd.exe, then I'm going to highlight that in red. So I'm going to add some dirty word searches to the processes that's pulling out all this information from my system. All right, now once I've done made any customizations to this JSON file, and again, you don't have to do any of this, you can just click next. Once I've made those customizations to that, I can then confirm, and it's going to begin analyzing my database. It's going through the entire database, and it's putting together timelines for all of the different processes that have run on my system, for the different network connections that have run, and the different things that have consumed battery. I'll be able to see which processes ran, who ran them, how long they were in the foreground, how long they were in the background, how much battery was consumed. And this is going to take a little bit of time to generate the response. It's a pretty fast version of this compared to previous versions. And when you consider all of the things that it's doing for you here, but this will probably take 2 to 3 minutes to run. So while that's running, we'll come back to that at the end. While it's running, we're going to go ahead and we're going to jump into our application. All right, so let's talk about command injection. We'll go back to those results when we're done. I've got a web app here, and this web app is a Flask app that basically just asks for a command and then gives you back those results. In Visual Studio Code here, this is the entire app, which I'll explain to you a little bit of in a moment. We're going to come up here, we're going to say run, and let's just run it without debugging. Okay, so my Python program is starting up this web application, and over here you can see what it does. It's a ping application that I can put in an IP address, and it runs it. If I put in 8.8.8.8, you can see that, oh, it pings 8.8.8.8, and it shows me the response. Now, the way that this works, and this is very typical, in this case, it's just a simple ping utility, but the number of web applications out there that do something like this in the background, it's numerous, right? Very often it's not just run a ping command, but you might provide, I don't know, an employee ID or a customer ID number, and then it runs some application or process on the background, a command line process, which interrogates their backend systems, and then those things give you back responses that the web page then consumes and presents back to you. So there's might be a little more complications. I'm keeping this simple so we can look at the vulnerability, but and whether or not there's a ping application, although you can find those, there are much more practical implementations of this that you'll find used more often. So what we see here in this web app, and let me clean some of this up so it's easier for us to see here, is we got a Flask web application, and down here it just starts running the app listening on port 8000. Okay, now this can be delivered via Nginx and other things rather than this Flask application. Many Flask, Django, and other web frameworks work the same way. What you'll do is you'll tag a function with how you want it to be consumed. And here you can see that I'm posting this at the root of this, but if I was to copy that, come up there and say, hey, also post it at /mark, right? This is just the URL that's terminating this particular thing. So if I stop that and I reload this web page here, then right now, instead of going to the root of this, if I go to /mark, well, now it also appears there. If I go to Mark 2 or something else that's not there, then it's not terminating it there, right? But here, we'll go back to the root of this. So this little decorator, which we have here, says where I want this function that's down here to listen and respond. Now, we talk all about decorators in 673. So if you want to learn more about those, I can teach you that. It's more of an advanced subject, how they work, how you can write your own, things like that. But this index function here, it is the thing that runs whenever it receives a request. So in here, I look and see if you did a post request, then what I do is I capture the value that you gave me, which in this case, an IP address, right? I'm going to just get that from the remote machine, and it's a thing called target, right? If we look over here, I'll see that if we come back to my HTML that's here, that Control-F target, right? Target is the name of this field that you're filling in on that web page. Okay, so I grab the target there out of the web response, and I'm going to call that target. And then this is where we are going south here. Well, actually, not really. In this case, we have to do this. I build a command called ping, and I pass the target as the last option, ping one time, and then we do a sub-process run to say, go run that command and capture the output, and then take the output and send it back to the attacker. All right. Now, the problem here is that if I restart this application, I can come in here and I can type things like 127.0.0.1, semicolon, ID, semicolon, LS, semicolon, or ls-la, semicolon, who am I? Right? I can run all of these different commands, and it just takes all of those different commands and it's going to run ping-c. If I was to come in here and put a breakpoint here, and let's run another command in here, 8.8.8.8, semicolon, who am I, semicolon, ls-la. If I set a breakpoint, I must have started without debugging. So let's create our breakpoint, come in here and start debugging this program and do that again. All right. Eight. There we go. Let's just select that one. All right. So now if we look at the command that's being executed here, we can see that the command it's executing is, well, all this. So it's as though you typed that at a bash prompt. Now, the reason it's as though you pass that at a bash prompt is because when the developer wrote this web page, they included this very dangerous line, shell equals true. Shell equals true says launch a bash prompt or a command prompt on a Windows system and do these things. If I erase that, then the command won't be run inside of a shell. Instead, it would be just an independent process. And so actually removing that shell equals true removes a huge attack surface for you. Now, when you do that, your command can't be a string anymore. So it has to be a list of options. So we'd have to turn this into a list. I'll tell you all about what lists are in 573 in our introduction. So if I change that to command.split, and now I rerun this application, we'll do it debugging. Sure, let's run it as a debugged program. All right, there I'm going to remove that breakpoint. I don't actually need to stop there. And let's go to port 5000, and we'll go to 127.0.0.1 semicolon ID. Okay. So now I can see the command here is, well, it looks the same at this point. I haven't done any filtering of input. So, but the problem is that when I try and do a sub-process run, something is going to happen here. Let's watch. Sub-process run, it's going to build out my command. Let's actually see if I can clean up my screen, make this a little easier for you to see, get some of these things out of the way. We're going to build the command, capture the output, capture the text, set a timeout, and it still ran. Let's see. Oh, I still got some output. Looks like it still worked. Nope. Temporary name ID failure. What is that? Actually, it didn't run my command because it wasn't inside of a shell. So because it didn't have all of that support that's there, that the supporting command shell, the backticks, the semicolons, and all of those other things don't work. It still works though with if I just give it an IP address. Let's remove that breakpoint, let it run. Ping 8888. Ping 88. Oh, I got a breakpoint. Sorry. I thought I removed it. Right, so we still get our responses there, but as soon as I try and do a command injection, it's not working. Okay, so that's one step that we can do in developing these applications to prevent these types of attacks. Another thing that we can do, and this is probably the most common solution that you see. Making sure you're not setting shell to true is probably not what's talked about most often. Most often, what we would do is use input validation. Right. So what I could do is here I could say something like if not re.match, and then I can provide a regular expression here that says, look, I want digits between 1 and 3 digits, and then that's going to be followed by a literal period. Okay, and let's just copy that because I'm going to do that with 4 octets. Okay, 1 octet, 2 octet, 3 octet, 4 octet. The last one doesn't have a period after it. Okay, if it does not match this, right? If I don't give it 4 octets of 4 periods, then you know what I'm going to do is I'm going to terminate this, or I'm going to have my function here return a value before. Actually, let's close this down so you can get a little more room. I'm going to return out, and the output is going to be not a valid IP address. Right, so now when I run this, if I don't give it an IP address that matches this regular, I got to match my regular expression against something. So I'll say match it against the target. Then it's going to give me back this error message. So we'll restart this program here. Now we're listening on port 5000. We'll come in here. Let's try and type 8.8.8.8. Make sure that we're still good. All right. Well, let's give it a different IP address. 127.0. Let's try 127.1.1.1 just so we see something different down here. There we go. And let's try it with 127.1.1.2 semicolon. Who am I? And service not known. That regular expression did not match. Let's see what happened there. If not RE match, let's put a little breakpoint here and see why that didn't match. 127.001 semicolon ID. All right. Target is this. And so one of the things that we can do with this debugger, and here we're getting into a little bit of 573 material where we try to understand how to use the debugger, things like this is, I can come up here and let's look at what my target is. You notice here, I hover over that. It shows me that. I can just take this little bit of code here. And while my program is executing, so this is still in the process of responding to that web server, I can come here to the debug console and I can paste Python code in there and see exactly what comes back. And actually, that did match. Oh, because, all right. So it's got my IP match. What that does is it says, does this IP address appear somewhere in the string? So I need to say, does this IP address, is it the only thing that's in the string? So what I need to do is modify my regular expression to here to say it has to begin with the IP address and it has to end at the end of the IP address. Regular expressions can be very complicated. And regular expressions are something that we'll deep dive in for you. We'll deep dive into how regular expressions work in 573. So now let's come back over here. Let's try this web page. And so now if I give it something that's not an IP address, I get not an IP address. So by using both input filtering and disabling that shell equals true, I have a very strong defense against things like command injection attacks. All right, with that, I got 2 minutes left. Let's come back over here. Here's my output to Scrum Dump. So it says I've exported this number of records. What kind of useful information can I get from Scrum Dump? If I come back over here, I see that it's generated a spreadsheet. And in this spreadsheet, now this is live analysis on my host machine that's given this presentation. Here I'll see all of the different fields that it's extracting, right? Here's my energy use. Here's my network use. I can see the names of the processes that have run on my system. And the user that ran them, the network that they were connected to, that's the name of my home Wi-Fi, the number of bytes that were sent and received across this network. So I can come down here to the application timeline. I can see all of the processes that have run along with the date and timestamps that they ran. Who ran that process? There's my local account, LO127 on there. The end time of when that process ran and other pieces of information that's in here. I wonder, we also have drop-down filters here. So let's come in here and try back. Let's try and look, see if I have any back. Oh, my keyboard is stuck over here. I'm typing in my program, darn it. All right, release my keyboard there. Let's come back over here and look for backdoor. Oh, no backdoors there. How about on my application resource usage? Do I have any backdoors here? Oh, I do have some backdoors there. And you'll see that when I do those highlighting, that highlighting that we did in that initial dirty word search, right? It's highlighting those things to make them stand out, make it easier when you're just scrolling through the list of things. Let's look for CMD, right? Here's all of those CMD.exes. You can see that they were highlighted in red to make it easier as you're processing those. All right, with that, it's 10:15, and I think that is my 30 minutes. Hope you've enjoyed this. Download Scrum Dump. It's for free. Let me point you at the URL that's on. It's my calendar. GitHub.com/markbaggett Scrum Dump. If you come over here to the releases, you'll be able to download that same version that I just showed you. Brand new release this week. Read all the documentation on how you can modify that configuration file and use those different dirty words and things like that to highlight things. That's what I have. Any
Very
questions?
cool. Well, so the only question I had thinking about this, I mean, plenty of questions, but the question that I want to fit in here for a high level overview on some of this is, of course, before I get into that, all amazing stuff, very very cool forensic things there, and awesome demonstration of the inner workings of some of those kind of command injection vulnerabilities. Always a useful thing to know. Um, is there anything going on in the Python world right now that's incredibly exciting? Like what's new, or what are some of the things that are is there any like I don't follow Python super closely, but I
Right.
know as things
Well,
are continuously evolving, like where is the language and other things like that going? Anything that's exciting you?
I mean, so the aspects of the things that are evolving in Python, I tend to not get that excited about. Oh, they've introduced the walrus operator or something like that to Python. The thing that I get excited about is what is happening in the world that doesn't use Python, right?
Great question.
AI, the AI revolution is upon us, and if you speak AI, if you speak Python, you speak AI. So I've just been working on applications after applications of Python, interacting with LLMs to ask questions to have them automate things in my command prompt. And it's kind of fun and scary that I was just doing is I send a prompt off to an API, and you can get Gemini. Gemini gives away API keys for free, right? So you could do this now with no cost to you whatsoever. Little Python program that gives it the Google Gemini API key. And I first prompt Gemini by saying, hey, pretend like I'm a bash prompt. And what I want you to do is send me Linux commands and interrogate me to see if there's any type of vulnerabilities in my system, right? And then I send that off to the prompt. I said, so from this point forward, I'm a bash prompt. Don't give me anything that you wouldn't give to a bash prompt. I'll respond as a bash prompt and let you see the results. Interrogate my system, figure out what's going on. Send that off as my prompt, capture the response from LLM, run it in a bash prompt, capture the results, send it back to the bash prompt, and then just sit there and watch my LLM interrogate my system, find vulnerabilities. Oh, maybe you should change this configuration file. Maybe you should change this configuration file. And the Python code to do that is, yeah, I mean, 30 lines of code to, well, the bulk of it is the LLM prompt that tells them what to do. The actual code to interact with the remote systems is trivial. And here's the other thing. You can ask LLM to write the code for you that writes the code. But the problem is if it doesn't work, then, well, you have to know Python in order to fix those errors and to make it work because it's not there yet where it can just write its stuff.